Hi everyone and welcome back. In today's video, we are going to discuss about the ephemeral values and the write-only arguments. Now before we discuss about this relatively newer feature, let's look into some of the challenges that most of the organization faces. Now, whenever you want to create resources like database, you'll also have to supply the appropriate password. So generally what happens is that organizations, they add the sensitive equals to true for the sensitive data like the passwords. Now the issue here is that in the case where you add sensitive equals to true, it only gets redacted from the CLI output. The actual value will still be written in the plain text in the terraform.tf state file. Now in such cases, the terraform.tf state file becomes the most important aspect. In case if it is leaked, then the attacker will be able to read all of the important data like the API keys, the database password, and so on. So this is something that you do not really want. Now let us go ahead and try this out practically. So what we are going to do, we are going to create a simple resource of random password. This is going to generate a 16-character password. And the database that we are going to create in AWS, this database will have the value that is generated as part of this random password resource type. Along with that, we also have a simple output values where we are providing the database password, whatever it gets generated, and we are adding sensitive equals to true. Now from the CLI, let's quickly do a Terraform apply with auto approve. I just wanted to show you the state file after the apply is completed so that the first slide is clear. Since that is the base slide, it will make the further topic easy to understand. Now within the CLI output, you see the output values that we are providing, the DB password, it is showing a sensitive value. So it is this specific one, the DB underscore password. Now, although this is showing a sensitive value, the users might assume that even in the state file, the value might either be encrypted or it will not be present, but that is not the case. In the terraform.tf state file, you will see the plain text value directly. So let us quickly wait for this apply to complete. Generally, the database creation takes time. It can take sometimes around 5 minutes. So we'll quickly wait over here. Alright, so it took around 5 minutes and 2 seconds and a resource is finally created. So if you see in the output values, you have the DB underscore password and it is showing as sensitive. Now if you try and explore the TF state file over here, let's quickly do that. You see in the output values itself, the first thing that you see is the plain text value of the DB underscore password. So even though sensitive is true, but still you are seeing this as a plain text value. And this is what the first slide states, that even though you add sensitive equals to true, still the plain text value gets added. And this is the reason why protection of the state file becomes very important. So let's do one thing before we just proceed further. I'll just quickly destroy this because for the next set of practicals also will require the newer creation. So this is where our first learning for today's video comes into picture, which is related to the ephemeral blocks. At an overview, the ephemeral block defines the resource that are essentially temporary. And one of the interesting part here is that this resource, the ephemeral resources, have a unique life cycle, and Terraform does not store information about the ephemeral resource in state or plan files. Now in our previous code, we had defined the resource of random underscore password. Now this time the notion is slightly different. Instead of resource block, you provide the ephemeral block. Now one more thing that I wanted to show you, that it is not just the output block where the password is stored, but if you remember in the resource block also we had defined two resources. One was the AWS DB instance, second one was random underscore password. So if you look into the resource of random underscore password, let's go a bit down. So now we are in the resource of random underscore password. Even over here in the result you see, we are getting the plain text value, very similar to the value that you are seeing as part of the output block. So even if you do not mention the output block, even if you just have this highlighted resource block and you do Terraform apply, still the password that gets generated as part of the resource of random password, that password will be stored in the TF state file. Now when you use the ephemeral block, this time the only difference here is you are not using the resource block, you are specifying ephemeral, and rest everything remains to be the same. In this case, Terraform does not store the information in state or plan files. Let us also quickly look into this. Now let me do one thing. The previous resource that we had used for demo, let me just comment it out. Now this resource of random DB password, I'll just change some resource to ephemeral. Alright. And our destroy is completed. This is good. Now when we do a Terraform plan over here, you see it says no changes to infrastructure, or when we do a Terraform apply, wait auto approve. Let's try. The apply is completed. When we look into the TF state file, you see we are not seeing anything over here. Now opposed to that, if we change back to resource over here, resource of random password, let's clear the screen. Let's do Terraform apply. The apply is completed. Now when you look into the state file, you see you are able to clearly see the password that was generated as part of this block. Alright, so I hope with this you understood the importance of ephemeral blocks. So generally in documentation also you will be able to see both the resource. For example, this is a normal resource of random underscore password, and in another page you have random underscore password, but this is a ephemeral resource. So if you see, you have ephemeral random underscore password. So this is one point that you have to keep a note of over here. The second important area that we have to be aware of is the write-only arguments. At an overview, the write-only arguments allows us to securely pass the temporary values to the Terraform managed resources during the operation without persisting those values to the state or plan files. Now in the first part, you are using the ephemeral resource over here, and then you are passing the value of that ephemeral resource as part of the DB underscore instance. And this is where you are using the write-only argument, as you can see over here. And again, if you are using this inside the DB instance, since you are calling this, because from here you are calling the value associated with the ephemeral resource, and this called value also will not be persisted as part of the state file or the plan file. Now let me also quickly show you. So for the resource of AWS underscore DB underscore instance, you see there is a note which says that write-only argument password underscore WO is available to use in place of password. So write-only arguments are supported in HashiCorp Terraform 1.11.0 or later. Now if you will see here, there will be two arguments that you will see. One is the normal password, and then if you go a bit down, let's say password underscore WO. One is this one. So if you are using normal password, for example, if you remember here we were using the normal password. So in this case also the value will be stored as part of the state file, which we do not really want. So this is the reason why instead of using the normal password argument, you make use of the password underscore WO. This is an optional one over here. So let's try a better way this time. What we are going to do, we are going to use the ephemeral of random password, and this time as part of the DB underscore instance. Now, in fact, let me do one thing. Let me show you one more interesting thing before we try this out. Let's say that you are using the ephemeral of random underscore password, and then you are trying to output the value of this in the output block over here. Let's also change this. Let's say ephemeral dot random underscore password dot DB underscore password dot say result. Alright. We'll keep sensitive equals to true. Now in this case, when you do a Terraform plan, immediately we are getting an error. What is the error? This output value is not declared as returning an ephemeral value, so it cannot be set to result derived from an ephemeral value. So basically it is stating that the ephemeral values are not allowed. So this is also one point to note, because ultimately this does not solve the purpose. You are generating a ephemeral value and then you are storing it as part of the state file. Alright. So this does not serve the purpose, and Terraform will restrict such operations. Now let's go back and let's uncomment this out. Now as part of the password over here, we'll replace it with password underscore WO. And then what we are going to do, we are going to use the ephemeral block ephemeral dot random underscore password dot DB underscore password dot result. This is one part. Now at this stage, this is not going to work, but at this stage when we do a Terraform plan, again you see it is stating that there is one more missing required argument, which is the password underscore WO underscore version. In fact, if you look into the documentation also, you have the password underscore WO underscore version. So this is used along with the password underscore WO. We'll be discussing why in just a moment. But first, let's go ahead and try it out. So I'll just specify password underscore wo underscore version, and we'll specify version as 1. Alright, let's quickly align it. I'll save this. Once you have done that, when you do a Terraform plan over here, this time everything should work. So at this stage, it is trying to destroy this random password resource. Why? Because it is part of the state file. As you can see, it was part of the state file. Let's do one thing. Let's make sure that we are starting from absolute scratch over here, considering that the state file should be empty. Let's do one thing. Let's go ahead and quickly destroy the state file and the resources. Alright, once this is done, you can verify the state file. No resources are created. Now you can go ahead and create both of these resources, Ephemeral and the DB instance with the write-only argument. So now let's go ahead and run the Terraform plan. Great, and this time we have the DB underscore instance that will be created. So let's go ahead and run the Terraform apply with auto approve. Now note that although in the plan stage it is showing just 1 to add, however, in the actual operation of Terraform, it is also loading the ephemeral random underscore password dot db underscore password, alright? So the password will be created over here. So this part should not confuse you. So this is one point to note. Again, since this is a database, it can take around 5 minutes to create. Let's quickly wait and we'll resume the video once this is created. Alright, so it took around 5 minutes and 12 seconds this time and our database is created. Now one thing that you will notice is that this time when you look into the state file, nowhere in the state file you will be able to see the password in plain text. In fact, let's go a bit down. This part, the password underscore wo, you see it is clearly showing it as null, so it is not available here. Terraform has no idea on what the password is all about. Alright, so I hope with this you understood the basics of the write-only arguments. Now before we discuss further, let's look into some of the important points to note. First one is that to use the write-only arguments, you must use the Terraform version 1.11 or later and use the resource that supports write-only argument. This is very important. Not all of the resource supports write-only argument, so you'll have to explore that. Second is write-only argument supports both the ephemeral as well as non-ephemeral values. The next important point to note is that Terraform does not store the write-only arguments in the state file. So Terraform has no way of knowing if write-only argument value has changed. This again is very important. So based on this, Terraform also cannot create the plan diffs for the write-only arguments because it does not store those values in the plan files itself. So this is one consideration to note. Now within here, this is the reason why providers typically include a version arguments along with the write-only arguments. And the Terraform stores the version argument in the state file and it can track if a version argument changes. For example, here you see we had specified that whatever password was generated, it is associated with the version 1. Now when you increment this version argument, then the password will also be updated accordingly. A newer password will be generated of this and it will be updated as part of the db underscore instance. So the version argument is the only thing Terraform can see. The password argument is something that it cannot see. So this is what the next slide is all about, which states that to trigger an update of a write-only argument, you can increment the version argument value in your configuration. So if the version argument value was 1 earlier and now you put it as 2, then it will fetch the new password, a newer password will be created and the newer value will be updated as part of the password underscore wo and it will be added to the appropriate resource. Now the question that comes is, since you are creating the database from Terraform and you do not really know the password, how are you going to connect to it? So this is also an important consideration. So what we are going to do, we are going to add one more resource for completeness of this video. Again, the resource of secrets manager that we are going to use for today's practical. This is not part of the exam. I am just giving you a better reference so that you understand the complete picture. So within here, let's go ahead and add few more resources. Primarily, we are going to add a resource of secrets manager just to understand the complete picture on how it might look like from the production perspective. We are doing that. Again, you don't really need to know what exactly this does. When the resource will get created, you will understand it when we explore it from the AWS console. But the basic idea is that whatever password that gets generated, we are storing that password also as part of the secrets manager service in AWS. Alright, so this is the basic idea. let's do one thing. Let's increment the version. For example, let's increment the version from say 1 to 3. You can also do 2, that is also fine. Let's save this. And from the CLI, this time we'll go ahead and do a Terraform apply with auto approve. Since we have incremented the version over here, a newer password will get created and the password will get updated to the RDS resource, and it will also get stored as part of the secrets manager service. So currently it is modifying the RDS resource, that is fine. Till that time, let's go back to the AWS console. Now from the AWS console, let's quickly go to the secrets manager service. Secrets manager service is generally used to store all of the secrets. It can be the database credentials, it can be API keys and so on. And generally the idea is that whatever you store over here, it will be in encrypted form using one more service, which is KMS. So let's open the secrets manager service. Now within here you see we have one secret called as db_pass. If I'll quickly open this, associated with this, you have a secret value. So now you can go ahead and retrieve the secret value over here. As soon as you open this, you see this is how the secret value looks like as part of plain text. Now again, to retrieve the secret value, you will require the permissions. Since we are the root user or the administrator user, we are able to do that. But the normal user in AWS who does not have access to the secrets manager, they will not be able to retrieve the value in plain text. Alright, so here you see the apply has completed. So in the use cases where the ephemeral values are generated like the password, now since the password is not getting stored anywhere, you still require it to connect to the database or any other resource that you might create. So for that completeness, you can make use of the secrets manager service. Again, when you update this one more time, for example, when you update it from 3 to 4, a newer random password will be generated. The resource of DB instance will be updated, and also the newer password, whatever it will generate, it will get stored as part of the secrets manager service. And this is how the complete lifecycle looks like. Now, before we conclude this video, one very important point to note is that the implementation of the write-only arguments and their version arguments is provider specific. So you have to consult the registry for more details about your specific provider. Not all of the providers supports it. AWS provider supports it for a specific set of resources like the database. So only for those you will be able to use these specific ones. Great. So I hope this has given you better clarity about the ephemeral values and the write-only arguments. Make sure that you go ahead and destroy all of the resources that you have created as part of this practical. Otherwise you will be charged. So one very important point to note. So that's about it, and with this we'll conclude today's video.